Now let us see the concept of source transformation. So source transformation is the process of converting the voltage source which is connected in series with the resistance into the current source which is in parallel with the resistance, or vice versa, by applying the concepts of the source transformation. So let us see, before applying the source transformation, we have to understand some of the basic concepts of the source transformation. Let us see the first one. So here we are connected the voltage source in series with the resistance. So this can be replaced by the current source which is parallel with the resistance. The value of the current will be equal to it's as per the Ohm's law, it is equal to the V by R. Okay, and also the polarity of the direction of the current source will be indicated. It denotes the positive of the battery and tail denotes the negative of the battery. That is the direction we are going to retain. So similarly, when you have the two voltage sources which are connected in series, so with the positive terminal and negative terminal, and the positive of the other battery is connected to the negative, so we can assume that the voltage sources are connected in series. The equivalent voltage can be found out by these two batteries can be replaced by a single voltage source with the voltage equal to the V, which is nothing but V1 plus V2 when it is connected in series with the polarity plus minus plus minus. Suppose if we have the things which is connected, like if the battery is connected like plus minus and minus plus, so then the equivalent voltage source we are going to replace by taking the difference of the two voltages, V1 minus V2, V1 minus V2, or the difference will be taken as V1 difference of V2. So the direction of the battery will be retained, which is having the highest voltage. The polarity, the same polarity will be retained in this voltage source. So similarly, when the current sources are connected in parallel, suppose the current source is having the same direction, the equivalent one will be the equivalent current source is having the sum of the two current sources. Or if it is connected with the opposite polarity, the difference of the currents will be taken, and whichever the current is having the highest value will be there, that direction is going to be denoted in the current source. Okay. So similarly, whenever for the voltage source, if the resistance is connected in parallel, so usually across the resistance the same voltage will be there when it is connected in parallel. So we can neglect this resistance, and when you are solving in the problems, we can remove the resistance which is connected parallelly across the voltage source. So similarly, the same concept can be extended for the current source which is connected in series with the resistance, because whenever the current source connected in series, the same current flows to the resistance. We can remove or we can neglect this resistance when you are solving the problem. So by knowing this basic concept, let us see one problem by applying the source transformation, and we'll find out the required thing in the network here. Let us consider a problem to find the value of the Vx by applying the concept of the source transformation. So here, if you look into the circuit diagram, we can see the two resistors are connected in series, and these two resistors are connected in series, and there is a two battery voltage sources are there. One is 50 volts and 10 volts here. So since these two are connected in series, the equivalent one will be the 10 ohms, and 6 and 4 ohms are connected in series. The equivalent resistance will be the 10 ohms will be there. And here we have two batteries. One is 50 volts and 10 volts, and the polarity is minus plus connected to the plus and minus. So we need to take the difference of 15 volts with the 10 volts, because those two are connected with the opposite polarity. And the polarity of the 15 volts battery we need to retain, because it is having the highest magnitude compared to the 10 volts here. Okay. And in the meantime, let us read out the circuit diagram. So which is by rating equivalent one of this one. So let us retain the 10 ohms like that only. So the equivalent of these two will be the 10 ohms, and the difference of 15 ohms and 10 volts, 15 volts and 10 volts will be the 5 volts you are going to get, and the polarity of this battery will be retained, that is plus minus. The voltage is 5 volts, and the equivalent resistance is 10 ohm. Similarly, for this branch, we have the equivalent resistance is 10 ohm, 6 plus 4, and the voltage source you are going to retain like this only. So it is 20 volts with the same polarity we are going to retain. And also, since these two are short circuited, let us bifurcate this part of the network with this part, so that we can apply the source transformation and convert this voltage source into the current source. We are going to retain this part of the network as it is. Let us draw the circuit diagram like this. So this is plus minus 10 volts, 5 ohm and 5 ohm. Okay. Now what we can do is, since the voltage source is in series with the resistance and this voltage source is in series with the resistance, let us apply the source transformation and convert the voltage source into the current source and convert the voltage source into the current source. So these two current sources will come in parallel. And similarly, in order to solve this one, here also we are going to convert the voltage source in series with the resistance as a current source in parallel with the resistance, so that we can find out the equivalent resistance of this one. So let us apply the source transformation and redraw the circuit diagram. So this 10 ohm we are going to retain like that only. And this part of the network, let us apply the source transformation, so that we will get the current source is in parallel with the resistance for this one, and similarly this voltage source will become equal to the current source in parallel with the resistance. This is for the first part of the network. And for the second part, the voltage source will become equivalent to the current source. And let us write the values. Let us find the values here. And the polarity of this one, the plus denotes the head of the current, and minus denotes the tail, and equivalent current will be equal to the, so I is equal to the, as per the Ohm's law, it is V by R. So it is 5 by 10 ohms, it is 0.2 amps will get, 5 ones are, 5 twos are, sorry, 0.5 amps will get. And the resistance value will be retained 10 ohms. For second part, so this is having a 20 volts, so 20 by 10 will be the 2 amps will get. The direction of the current will be the same thing. Okay, and 10 ohm resistor will be retained like that only. And for this part, let us find out the current. The polarity of the current will be the same as the positive denotes the head and negative denotes the tail. The current value I will be equal to the V by R. So V is 10 by 5 is 2 amps will get, and the resistance is 5 ohm, and this resistance is 5 ohm. So we applied the source transformation, converted the voltage source into the current source. Now what we can do is, we can see these two currents are in parallel with the same direction, so we can add up these two currents, and 10 ohm is in parallel with the 10 ohm resistance. Let us find out the equivalent will be the 5 ohms we will get, and similarly 5 ohms is in parallel with the 5 ohm, the equivalent resistance will be the 2.5 ohms will get here. Okay, so let us redraw the circuit diagram by finding the equivalent values. So here these two currents, let us convert into a single current source, and these two resistance, let us convert into the single resistance value, and the current source is single one, let us retain like that only. The equivalent of this one will get as a single resistance, and 10 ohms, here we need to find out the voltage Vx, we will retain 10 ohms like that only. The equivalent current will be the sum of 2.5 plus 2 amps, it is 2.5 amps, and the direction, both are in the same direction, both will be added, and 10 ohms parallel with the 10 ohms, so it will be 5 ohms will get 10 ohm parallel with 10 ohm, so it is 10 into 10 divided by 10 plus 10, so 100 divided by 20, so we'll get 5 ohms. So similarly 5 ohms is in parallel with the 5 ohms, it will become 2.5 ohms will get, and the current 2 amps will get. So this network we are converting into the simplified form like this. Now we can see the current source parallel with the resistance. We can apply the source transformation, again convert this current source into the voltage source, again convert this current source into the voltage source, so that the two voltage sources will come in series, and similarly the resistance will come in series. We can find out the voltage Vx we can find out here. So let us do the conversion of current source into the voltage source. So the 10 ohms here will retain like that only. So now apply the source transformation, so that the current source in parallel with the resistance will become voltage source in series with the resistance. The head of the current source will become positive, tail will become negative, and the resistance, the value will remain same 5 ohms. So similarly for this one, it will become the voltage source in series with the resistance. The resistance is 2.5 ohms. The current will become the voltage source. So this V will be equal to the I into R. So 2 into 2.5 So this will become equal to the 5 volts, and here this will become 5 into 2.5. This will become 12.5 volts. Okay. So and this 10 ohm will be there. We need to find out the Vx here. Okay. So we got 12.5 volts, and these two resistors are in series. Let us redraw the simplified network, or we can apply the KVL in this path only. Let us redraw it and write the circuit, which consists of single voltage source and single equivalent resistance. Since these two voltage sources are connected in series, so we can add up the two voltages, so it will become 7.5 volts, that is 12.5 plus 5 will become 17.5 volts, and 5 and 2.5 will become 7.5 ohms and 10 ohm, and the voltage is plus minus Vx. Now, in order to find out the voltage across 10 ohm, let us apply the KVL. Okay, by taking the current of the direction in the positive path. So apply the KVL. So start from the voltage source. The current, let us see the current I is nothing but it is flowing in the circuit. The current entering negative, leaving the positive. So we can take, so by apply the concept of KVL. Current entering negative, leaving positive, it is raising the voltage. So 17.5 minus, so 10 into I, which is nothing but voltage across 10 ohms, and minus 7.5 I is equal to 0. So send these two that side, so that we'll get the value for the I. I will be equal to the 17.5 divided by 17.5, 10 plus 17.5 will become 17.5. The current through the circuit will become 1 amps will get here. So once you know the current in the circuit, we can find out the voltage across the 10 ohm resistor. That voltage Vx will be equal to the it is 10 into the current I, so it is 10 into 1, which is but 10 volts we get here. Okay, so finally we got the value for the Vx across the voltage across the 10 ohm resistor by applying the concept of source transformation. Thank you.